Yep. Now here we are going to put some graphs where the function is not continuous, and then to write a rule in which the function is continuous at a given point. And let's say that here we have this graph. Five. Is the function here continuous at x equal 5?
لا،
Why?
لأن هايدي مش بوينت، هايدي البوينت اللي بتحطها الأساسية، هايدي بيضلوا ماشي اللاين فيها.
Because here 5 or x, the function is not defined at x equal 5. Here it is not a point on the graph. This point is not a point on the graph. So here 5 is not in the domain of the function. Let's say function 5 is not in the domain of the function, so not continuous. F is not continuous. F is not continuous at x equal 5. So the first condition, the function should be defined at the given number. As if here when we say it is not continuous because 5 is not in the domain. So to start talking about continuity, the number should be in the domain. So as if here we are saying the first condition, the number should be in the domain. Okay? Right. Let's give another function or another graph in which the function is not continuous at this point. Let's see, here we have 3. Here the number, let's say 2. And here we have 3. Is the function defined at 3?
Yes.
Yes.
Yeah.
What's f of 3?
2.
Sorry?
2.
2. The function is defined at 3. 3 belongs to the domain. And f of 3, as we said, we consider the bounded point. F of 3 is equal to 2. So the condition where the function is defined at the given point is 5. But is the function continuous? Graphically.
No.
It is not continuous. We have a jump. We have a jump. Like here we have a part of the graph. Here we have another part, which are graphically not connected. Vocabulary is like مفهومين بسيطين. Not connected, not joined. We have a jump. We have a cut in the graph. Not continuous. Okay. Now let's see here the problem that makes the function not continuous. What can you say about the limit of f of x as x approaches 3 minus and limit of f of x as x approaches 3 plus?
3 minus 2.
Limit as x approaches 3 minus.
2.
It's 2. As you said, 3 minus, so the left side of 3, the left side, so this part. Here is this graph. This graph is very close to this point. The y value is 2, so the limit as x approaches 3 minus is 2. What about limit as x approaches 3 plus?
3.
3 plus, the right side of 3, here we have 3. The right side, so this graph when x becomes close to 3, the graph becomes close to this point, and the y value is 3. So what can you say about the limit of f of x as x approaches 3?
Not defined.
Does not exist. The limit from the left is not equal to the limit from the right. So the limit here does not exist. Limit as x approaches 3 does not exist. The limit from the left is not equal to the limit from the right. So here, it's not continuous because the limit doesn't exist. Not continuous because the limit from the left is not equal to the limit from the right. So the function is not continuous. The second condition, the limit should exist. So the first condition, we said that the function should be defined. The first example I gave, the function was not continuous because the number is not in the domain. So the first condition, the number should be in the domain. Here, it's not continuous because the limit from the left is not equal to the limit from the right. So as if you are saying here, the second condition, the limit from the left should be equal to the limit from the right to be continuous. We'll give another example in which also the function is not continuous, where the limit exists and the number is in the domain.
استاذ،
Yes.
ان احنا بالساعة الماضية نهار التنين كملنا هوديكي مظبوط، ما اخدنا عنها.
لا ما اخذناش عن هون، كنت بدي بلش فيهم وراحت الكهرباء وما دور الموتور.
اوكي.
كنت بدي بلش بهون. طيب. To continue. Is this function continuous?
No.
No. Here we have a gap in this one. طيب. Is the function defined at 3? طبعا not continuous at x equal 3 at this number. Other parts, if you consider this part, it's continuous. This part continuous. But at this number only, it is not continuous. طيب. Is 3 in the domain?
Yes.
What is f of 3?
3.
F of 3, the bounded point, 3. F of 3 is equal to 3. Okay. What can we see here about limit of the and limit as x approaches 3 plus limit as x approaches 3 minus? What's the answer?
2.
2.
2. And limit as x approaches 3 plus?
2.
2. Because here, as we said, when you have to consider the limit, you consider the graph, the line. Okay? Here, the line from the left is close to this point. The y value is 2, so the limit as x approaches 3 minus is 2. And from the right, 3 plus, also the graph is very close to this point, y value is 2. Don't consider this bounded point. This bounded point gives the coordinates a point on the graph. F of 3 is equal to the y value here is 3. But not for the limit. The limit تاخد هيك. طيب. Does the limit exist? Does the limit exist?
Yes.
No. No.
Yes. But limit from the left is 2. The limit from the right is also 2.
Okay. بس
The limit
يكون equal.
exists. The limit of f of x as x approaches 3 is equal to. So here, the function is defined at the given number. The function is defined at 3. The limit as x approaches 3 exists. Limit from the left is equal to the limit from the right. But the function is not continuous. Yeah, the first condition is satisfied, defined. The function is defined. The second condition, the limit exists. But still, the function is not continuous. Why? Because the limit is 2, and the value of the function is 3. The limit as x approaches 3 is 2, while f of 3 is equal to 3. They are not equal. يعني, if this point, نزلناها لهون، لو هالبوينت محيناها حطيناها هون. Yeah. Will the function be continuous now?
Yes.
In this case, what is f of 3?
2.
2. So if f of 3 is equal to 2, which is equal to the limit, then it will be continuous. If we change here, f of 3, we wrote it 2. Yeah? So as if here we shifted this point to this point. Translate this point to this point. In this case, the function will be continuous. And in this case, the limit as x approaches 3 will be equal to f of 3,
Push up my.
which is equal to 2. So the third condition for the continuity
إذا بتشمل أنت
is that the limit
إذا أنت بتشمل
as x approaches the number is equal to f of this number. Limit as x approaches 3 should be equal to f of 3 in order to say that the function is continuous. So here we have three conditions. The function is defined at the given number. The function or the limit as x approaches this number, limit as x approaches this number is defined. And three, the limit as x approaches this number is equal to f of this number. And limit as x approaches a should be equal to f of a in order to say that the function is continuous. Okay? Is that clear? I forgot to write this idea in the worksheet, sorry, in the summary. I'll write it again and then I'm going to send it. Please write it on your copybook. The continuity.
أستاذ
هرجع اطلع على الورك شيت، سوري على السمري اللي بعتكم اياها اللي عم دربت